Hello everyone and welcome to .NET Core Central. Today I'm going to have a small application to show some of the features of NUnit. To do that, first I'll create a new project where I'm going to add a class with a couple of functions, and then I'll create a test project to demonstrate the NUnit features. I'll just rename this class. It'll be a simple calculator which will calculate addition and subtraction. Here I'm keeping the requirement that subtraction will never return a negative number, just to demonstrate argument validation and adding a couple of new test cases in the unit testing for negative testing. That's the only reason I'm doing that. So this is a simple calculator class. Now I'll create the project for NUnit, and then we'll write few test cases there. And then I will add the NuGet packages necessary for the unit testing, and that would be NUnit, the NUnit test adapter, and the Visual Studio test adapter to be able to integrate with the test menu here, so that when we go run all test, it detects the NUnit test. So first is the NUnit, which is, it was already there, I think, yeah. That's the first one. Let me install that. And then next one is the next two NuGet packages are for the Visual Studio adapter. First one is NUnit 3 test. NUnit 3 test adapter. Yeah, this is the one. And the last one I will add is Microsoft.NET Test SDK. I'll install the stable version. Okay, so now I'll go and rename this class to calculator test. Now, to be able to enable a class for unit testing in NUnit, we have to add an attribute called test fixture. Next, I'll create the test function. I like to create the test function names at very descriptive, and it helps reading the test results also. So from test result is very clear what we are testing. And for a function to be able to testable, we need to add the attribute test. This tells the NUnit framework that this particular function should be tested. So when it runs the test, it will try to execute this. Similarly, if we want to, let's say, ignore a particular test, we can just put an ignore attribute on top of it. So let's say I say a public void test to ignore, and then put ignore attribute. And just go ahead and run the test. We'll see that the first one will be tested out, whereas the second one will be ignored. It's showing some red squiggly. Oh, okay. So ignore it need to have an argument. So I'll just provide an argument. Now let's test. And here we can see that it has just picked up the test with the one which is test attribute and ignored the second test. Okay, now let's write a valid test case here. So we'll create an instance of calculator and test it out. So for that I have to add a reference to the NUnit demo project. Next, to verify the result, I am going to use assert. Assert is a class which has bunch of static method in it, which helps us verify the result. So basically the expected result versus actual result. And assert has a bunch of function, but in my experience most of the time I have ended up using r equal, catch is another one, contains is another one, and then maybe greater once in a while, is false, and is true. Apart from that, I have not used most of the other functions available. So let's say I think I've used that a couple of times, but otherwise r equal is the one which I mostly use. So let's use that. So first is the expected, which we are expecting 8, and actual is the results. So let's try it out now. Let's just run this function. Yeah, we can see it's success, but if I just change the expected result to 9, it should just fail. So I can also go here and run test. And you can see it's a failure now. So let's get it back to green. And we're back good. Okay, now let's test exception scenario, and we'll test that with the subtraction where we added argument exception. Now here, instead of just getting a result, we are going to use an assert function to see if it is returning an exception. I'll be using assert.catch, and assert.catch takes a delegate which will be used to call the function, and if that throws an exception, the test will be successful, otherwise the test will be a failure. So let's try doing that. First we'll have the test to be a failure, so we'll pass valid argument, and then we'll change it to pass the incorrect argument so that it throws argument exception. So now if we run the test should fail. The subtraction is taking 4 and 3, so where 4 is not greater than 3, so it will not throw the argument exception. If you remember in calculator subtraction method, we have if first is less than second, and that's when we are throwing argument exception. So let's run the test again. Oh, I have to provide the test attribute, which I forgot. Let's run it again. And we can see that this is a failure test. Now let's change the argument and make it 5 and run, and this should be a success now. Yeah, we can see that it's a successful test now. Now you can see that assert has two such function. One is assert.catch we have done, and another one is assert.throws. Now both of them looks very similar, and according to the documentation in NUnit, the difference between catch and throw is, in throw you expect a specific exception. In catch you can have a derived exception also. So for example, if I have, instead of argument exception, if I have application exception, this will still work, whereas in throws it should not. So let's try that out. So first let's try catch with application exception, then we'll try throws with application exception, and then we'll try throws with specific exception. Or am I saying it wrong? Probably throws is the one which can have oh, it's not application exception, it should be argument exception. So I have to change my code here to have a specific because if I go to the argument exception is derived from system exception, not application exception. So I can change the implementation here and have system exception. And test it out. Yeah, and you can see it is successful. Whereas if we do assert.throws, first let's try with argument exception, make it as green, and then we'll try with system exception, and it should be red. Yeah, as you can see it's green, and let's do system exception, it should be red. Yeah, you can see it's red. Now let's uncomment both the code, and both of them should be working as expected. Yep. Another thing I wanted to demonstrate is something called test case attribute, where we can run a test with multiple arguments and all of them can be driven by attributes. So for that, this is how we'll do. So in this case, this function will take int fast, and it will take a third argument, which will be the result, and I'll show you how it all ties up. So we'll use the result from the last as an expected. So let me make it as expected result. And next here, this is where the magic happens. I'll use the test case, and test case is the one where we can have multiple arguments. And so on and so forth. So I can just try test this now. So you can see that it has added 3 versions of multiple with individual arguments, which is really cool. And this can help doing repetitive testing for a particular function. The next thing what we can do is we can change the order of tests. So we can say a particular test should be executed before another one, and this is very helpful when you have some sort of dependent test cases. I can just demonstrate it. So we can give this one as order 1, and this one is order of 2, and then yeah, that's this too. These I'll just leave this for now. Selected the wrong option. Oh no, I think I did the right. Did I? So how do I know it really taken it? Let me give this maybe. I don't even know if this, yeah, it works. Yeah, looks like that's it. So let me go and try test all. Yeah. So to see that, actually, I think all I have to do is I have to debug through to see how the test execution order is. Yeah, as you can see, it has come to 1 first. Okay, which is expected. Then it came to 2. Then it came to 3. So and 3 will be executed 3 times, so it's okay. Cool. So this is another pretty cool feature. The next one I'm going to show, which is actually irrelevant at this point because my calculator doesn't need any sort of setup, but there are a couple of other NUnit feature which is setup and tear down, which can be used for let's say if you have a class which has some dependencies that need to be created in the beginning, it is very helpful. So let me just show this. So if we are like, if we want to dispose of something, then this is probably a good place. So let me do something just totally irrelevant, but I'll just end up doing it. So just for the demonstration purpose. So I do this iDisposable and just create a dispose method and just keep it empty for the time being. There is basically nothing to dispose here. But let's say we will be implementing something in future. So I do that, and then what I can do is I can declare the calculator object here the beginning, and in setup I'll say calc equal to new of calculator, and I can get rid of all these calculators here, so it leaves the same instance, which is totally okay. And then in the tear down I'll just say calc dot dispose, because it has a dispose method in it. And then I can put breakpoints here just to show, debug and show that it is following the path that we are expecting. So it'll go to setup, then run, and then go to tear down. So I can go and say run all tests. I should have done debug, but we'll do it again. So let me go and do debug all tests. As we can see, it came to setup first, then test on one, which will have exception twice, then tear down, then again setup, test 2, tear down, setup, test 3, tear down, setup, test 4, tear down. Oh, this has 3 tests. So as we can see that it calls setup and tear down, and it disposed of this object. The breakpoints. So these are few of the features that I found really helpful in my career. If you have any other feature and a use case, please provide comment below. And if you like these videos, please provide me a thumbs up and subscribe to my channel. Thank you. And I'll also provide the link to my blog in the description, where I'll have a little more info and some links there, and also the location of this source code. Thank you.